2016, there was around 222 million drivers holding a valid driver's license in the United States. This quote from Statista is startling and highlights just how valuable having the ability to drive around in a car is. However, most drivers on the road lack an understanding of how these cars are able to get us from place to place. Today, I would like to clarify how crucial this system in our society came about and how it functions. We owe our ability to get from place to place easily by the principles of the internal combustion engine. I have been able to learn a lot about engines from my experience working on them. Today, I would like to give you a brief history of the four-cycle internal combustion engine, followed by a basic anatomy and layout, and then tied all together with a brief description of how it operates. First, let's look at some history that brought us to the internal combustion engine. There were many influential inventors who tried and developed internal combustion engines. However, none were quite as successful as the four-cycle engine developed by Nicholas Odo. Before Odo created his designs, there were many genius inventors who were attempting to obtain the great power that could be generated from an internal combustion engine. As early as 1680, some inventors were beginning to develop internal combustion engines. However, they did not have the ability or processes to create their design. For instance, the history of the internal combustion engine states that Dutch physicist Christian Huygens designed but never built an internal combustion engine that was to be fueled with gunpowder, and that's an example of it right there. As technology, processes, and industry may develop, some of these engines were beginning to be built. The Dutch Museum states that in 1860, the Frenchman Jean Lenoir constructed a gas engine that was immediately accepted by all. For a while, this engine became a sales success because it ran with relatively low noise. However, this engine still consumed way too much fuel and lubricant and it cost too much money because of that. And here's an example of that. For the internal combustion engine to become more used on a big scale, these engines needed to simply become cheaper to operate and user-friendly and more reliable. So in 1876, Nicholas Odo created his version of the internal combustion engine. The importance of this revolutionary design was the use of a four-cycle system which consisted of intake, compression, power, and exhaust. The Dutch Museum states that in this type of engine, extraneous ignition caused the fuel air mixture to ignite and explode. A spark plug provided the means, although in earlier engines a naked flame was used. And according to the history of the internal combustion engine, Odo's contributions were historically significant. It was his four-stroke engine that universally adopted for all a liquid-fueled automobile that sent us forward. Now let's look at some of the components of the four-cycle engine from Odo's cycle. The key components that we'll look at is the crankshaft, connecting rod, piston, the intake and exhaust valves, and the spark plugs. So in this picture you can see in the blue over here, that's your piston, and it's reciprocating up and down. Then in the red is your connecting rod, and its job is to transfer that reciprocating motion to the crankshaft. The crankshaft is in green, and it's very important because its job is to convert reciprocating motion into rotational motion. And then we'll look at a good example to compare this to is a bicycle that's used today. So your feet are going up and down reciprocating, and that's causing the rotation of the gear to send your bike forward. The next component group we'll look at is the intake and exhaust valves and the spark plug. So Your intake valve, the purpose of it is to allow the fuel air mixture to enter the cylinder. And then your exhaust valve, the purpose of it is to open up and allow, after the fuel air mixture is burned, it allows the exhaust gas to exit the cylinder. And then the spark plug, its job is to ignite the fuel air mixture. Makestuff.com states that a spark plug delivers electric current to the combustion chamber, which ignites the fuel air mixture, leading to an abrupt expansion of gas. Therefore, we know the intake lets the fuel in, the spark plug ignites it, and the exhaust lets the gas leave the cylinder so the fresh mixture of fuel and air can come in and the cycle can repeat itself. So now that we see some of the components, we'll take a look at how it all works together. So each of these components work together in 4 basic parts of the cycle: intake, compression, power, and exhaust. For reference, I'll be using this picture by Haynes.com. So on intake, what happens is your crankshaft is spinning and it pulls down on your piston. And while it's doing this, your intake valve is opening. And what that does is it creates a vacuum and it pulls in your air-fuel mixture. And then on compression, the piston moves up and both valves are closed, which lowers the volume of the cylinder and it creates compression in the cylinder. And then at the very top of the stroke, your spark plug will ignite. And when this happens, it'll cause a great expansion of gas, which will push back down on the piston and then the connecting rod to the crankshaft, and that'll cause all your power that drives your engine. And then what happens after that is your cylinder will rotate around, come back up, and it'll push your exhaust gas out. So today we have discussed the internal combustion engine beginning from its origins in the 1600s. We owe so much to this process to the developments of Nicholas Otto. I hope you guys have a better understanding of how simple this is, and I hope you have a better appreciation of how revolutionary this design was. Moreover, I hope you have a better appreciation of how the development of the 4-cycle internal combustion engines drive our world.